Hey, we've got someone in chat. Hello, Francois. I'm thinking I'm thinking that's I've got your name right. Hopefully. What can I tell you about Keras? I know only a little bit about Keras. I know it's like a framework for machine learning. Um, I think it packages doesn't it package some PyTorch things to make them more convenient to use? But do you have a specific question about Keras? Also, am I saying Keras right? I haven't actually looked it up to verify that. You still there, Francois? Francois asks, "Do you find something? Can you tell me the name of the author?" I don't think there is a single author, but let me pull up what I'm finding here. Let's read about Keras. Keras is a deep learning API written in Python running on top of the machine learning platform TensorFlow. It was developed with a focus on enabling fast experimentation. Francois says, the main author. Keras was initially developed as part of the research effort of Project Oneiros, open-ended neuro-electronic intelligent robot operating system. Francois says, try to search it in Wikipedia, please, you will understand. Okay. Wikipedia, Keras, author. Well, now I see the name is Francois. I want to say Cholet. I'm sure I'm not going to get it right, so I won't keep trying. Okay, Francois, you have my attention. I don't know whether to assume that you are the Francois who wrote Karis, or if you're someone with the name who's having a good time on Twitch. You are a recruiter from Google? This just gets stranger and stranger. Okay, I'll play along. Google Recruiter, what do you have for me? So I'm going to say, if you want my email, go look on my YouTube channel and click the About section, and you'll find... I don't mind saying it, but I'm not going to... It's info@ericcodes.com. Have I done something on GitHub? Yeah, there should be a bot command for my GitHub. Hold on, let me see if it works. Yeah, it does work. Can you explain me the 2 eggs problem? What is the 2 eggs problem? You are really interested in the 2 eggs problem. Okay, 2 eggs problem. You are given 2 eggs, access to a 100-story building. Both eggs are identical. The aim is to find out the highest floor from which an egg will not break when dropped out of a window from that floor. If an egg is dropped and does not break, it is undamaged and can be dropped again. However, once an egg is broken, that's it for that egg. If an egg breaks when dropped from floor N, then it would also have broken from any floor above that. If an egg survives a fall, then it will survive any fall shorter than that. Question, do these eggs have memory? Like, if I drop it from floor 5 and it survives, but then I drop it from floor 5 again and it breaks, is that something that could possibly happen? Or is... I think I get the point of that. The question is, what strategy should you adapt to minimize the number of egg drops it takes to find the solution? And what is the worst case for the number of drops it will take? Well, I don't know much about dropping eggs off of buildings. My first thought is to take the binary search and start at floor 50, and probably the egg breaks. Let's just say the egg breaks, and then cut that in half and go to floor 25. And if that egg breaks, then you want to check floor 12 and a half, except you can't do that for 2 reasons. There is no 12 and a half, but more importantly, you've broken both of your eggs. So the careful strategy would be to go n equals 1, n equals 2, n equals 3, and that way you're guaranteed to not lose your eggs, but you might as well throw away one of the eggs and maybe guess that, like, I don't see the point of checking 10, because that seems like way further than where an egg would break. So I would say pick a lucky number between 1 and 10, and if that doesn't break the egg, or if it does break the egg, either way, it's kind of a silly problem. Okay, so Mr. Machine Learning Framework author and Google recruiter, how did I do? Do I get the job at Google? What is the best algorithm to control the data flow in the modern CPU? I'm just gonna Google that. Modern CPU data flow algorithm. There is no answer. To which? The egg question or the modern CPU question? The second one. Data flow algorithms for processors with vector extensions. The purpose of this paper is to prevent one such approach, for so doing in the case actors that maintain state. Encyclopedia Dataflow.pdf, Computer Systems Research Lab. The data flow model of computation offers an attractive alternative to control flow in extracting parallelism from programs. These links are going to go pretty deep pretty quick, so I don't think I'm going to learn much from that. Okay, what do you got for me next? Oh, we can start another timer. Do I like streaming? Yes, I like streaming. I like it a lot. Especially when there's someone interacting in the chat, which I have now, so I'm enjoying this. Would I work at it as developer? I'm not entirely sure what you're asking. Are you asking, like, would I work as a developer while streaming? Is that what you're asking? If that's the question you're asking, then the answer is yes, I would. I would work as a developer while streaming what I was doing. I don't know if there's a company out there that wants that kind of thing, but that's a thing that I would do. I'm asking. Francois says on Twitch, I'm asking me if you ever worked as a developer in the streaming field. Against Twitch. No, I've only worked as a data engineer, and not for anything in the streaming field, and not even streaming applications of data engineering. It's been batch process stuff. Although I think we're talking about two different definitions of streaming now. How many years of work? I have like a little more than 2 years of work experience that's in data engineering. Before then, I was doing. Do you know Google Brain? Is that something to do with their AI team? Brain Team Google Research, make machines intelligent, improve people's lives. Google Brain Team members set their own agenda, working on everything from pure to applied AI research. Teams, Brain Research, make machines intelligent, improve people's lives. History of breakthroughs. Google Brain started in 2011 at X as an exploratory lab and was founded by Jeff Dean, Greg Corrado, and Andrew Ng, along with other engineers, and is now part of Google Research. Since then, we continually rethink our approach to machine learning and are proud of our breakthroughs, which include AI infrastructure, developing TensorFlow, Francois says, there is not my name there. Damn. Well, I'm sorry your name's not there. Should I talk to Google about it? Or should you talk to Google about it, since you're a recruiter for Google? Francois says, Jeff was not kind. Sequence-to-sequence learning, leading to transformers and BERT. AutoML, pioneering automated machine learning for production use. Our research breakthroughs enable Google's mission to organize the world's information and make it universally accessible and useful. That's interesting. Google Impact. As part of Google and Alphabet, the Brain team has access to resources and unparalleled collaboration opportunities that have a positive impact on products and society. Our broad and fundamental research goals allow us to collaborate with and contribute to many teams across Alphabet, which deploy our cutting-edge technology into products used by billions of users, positively impacting society and the research community. Making the world a better place, as Silicon Valley would say. Now Francois says, how they pay you. I don't understand the question, so I'm going to continue reading about Google Brain while I wait for you to clarify the question. Open and bottom-up culture. We believe that openly disseminating research is critical to a healthy exchange of ideas, leading to rapid progress in the field. As such, we regularly publish our research at top academic conferences and journals, and release our tools, such as TensorFlow and JAX, as open source projects. What is JAX? GitHub Google JAX. Composable transformers of Python plus NumPy programs. Differentiate vectorize GT to GPU, TPU, and more. How about read the docs? That'll tell me something more about it. JAX is AutoGrad and XLA brought together. How many years of experience do you have? Says Francois. I have 2 years. You said I could send you my book. What book is that? Brought together for high-performance numerical computing and machine learning research. It combines composable transformations of Python plus NumPy programs, differentiate, vectorize. This is going over my head a little bit. Composable transformations. Does that mean transforming it into other runtimes? Let's do tutorial JAX 101. This is a tutorial developed by engineers and researchers at DeepMind. This looks interesting. JAX has accelerated NumPy. Okay, this is looking like it's actually going to explain something. Fundamentally, JAX is a library that enables transformations of array manipulating programs written with a NumPy-like API. Over the course of this series of guides, we will unpack exactly what that means. For now, you can think of JAX as differentiable NumPy that runs on accelerators. Differentiable. Francois Cholet says, I thought people was more happy to have a possibility. Nice to meet you. Spelled M-E-A-T. Nice to meet you too. Is that a way of saying goodbye? Are you done now hanging out? differentiable numpy. I'm assuming that doesn't mean like the calculus version of differentiation. I'm assuming it's more like something computer sciencey. Import jax.numpy as JNP. So it's a Python library. Open in collab, sure. Import jax.numpy as JNP. X equals jnp.arange10 print x. Not sure, let's run that. Warning, no GPU TPU found, falling back to CPU. So far, everything is just like NumPy. A big appeal of JAX is that you don't need to learn a new API. Many common NumPy programs would run just as well in JAX if you substitute NP for JNP. However, there are some important differences which we touch on at the end of this section. You can notice the first difference if you check the type of X. It is a type variable of type device array, which is the way JAX represents arrays. Device array 0 through 10, dtype equals int32. One useful feature of JAX is that the same code can be run on different backends: CPU, GPU, and TPU. Okay, TPU processor. Tensor processing unit. Neat. A tensor is like an array, but in more dimensions, potentially. We will now perform a dot product to demonstrate that it can be done in different devices without changing the code. We use timeit to check the performance. Technical detail. When a JAX function is called, including jnp.array creation, did we do jnp.array? We did do jnp.arange of 10. The corresponding operation is dispatched to an accelerator to be computed asynchronously when possible. The returned array, therefore, is not necessarily filled in as soon as the function returns. Thus, if we don't require the result immediately, the computation won't block Python execution. Therefore, unless we see block until ready, or convert the array to a regular Python type, we will only time the dispatch, not the actual computation. See asynchronous dispatch in the JAX docs. That makes sense. We're dispatching the calculation off to somewhere else. Long vector equals jnp.arange. So the dot product of a vector that's the numbers 1 through 1 times 10 to the 7th. So they're calculating 1 times 1 and 2 times 2 and 3 times 3 and 4 times 4 and so on all the way down. Timeit jnp.dot. Dot block until ready. Oh, so we are actually waiting for it to actually do the thing. .67 milliseconds plus minus 70 microsecond per loop of 7 runs, 100 loops each. Tip: try running the code above twice, once without an accelerator and once with a GPU runtime. While in collab, click runtime, change runtime, and choose GPU. Want to access premium GPUs? No thanks. We've connected a new runtime. Would you like to terminate the previous runtime? I guess I need to import Jax and jax.numpy as JNP again. "28 microseconds. Jax first transformation, grad. Probably for gradient. A fundamental feature of Jax is that it allows you to transform functions. One of the most commonly used transformations is jax.gradient, jax.grad, which takes a numerical function written in Python and returns you a new Python function that computes the gradient of the original function. To use it, let's first define a function that takes an array and returns the sum of squares. Define sum of squares of x, return jnp.sum of x star 2. What type of thing is x going to be? It's going to be a JNP type. Applying jax.gradient to sum of squares will return a different function, namely the gradient of sum of squares with respect to its first parameter x. Then you can use that function on an array and return the derivative with respect to each element of the array. Sum of squares dx equals jax.gradient sum of squares. X equals jnp.asArray 1, 2, 3, 4. Print sum of squares of x, 30. Print sum of squares dx of x. I'm used to thinking about the gradient operator. You can think of jax.grade by analogy to the delta operator from vector calculus. Given a function f of x, delta f represents the function that computes f's gradient, i.e. delta f of xi equals delta f with respect to x of x, okay. Analogously, jax.gradient of f is the function that computes the gradient, so jax.grade of fx is the gradient of f at x. Like delta, jax.gradient will only work on functions with a scalar output and will raise an error else otherwise. Oops. We need to define sum of squares. When we run sum of squares, gets the same output. I don't think I'm going to go deeper into this right now. Sum of squares dx, jax.gradient of sum of squares. I don't know. Let's go to the BRB screen.